Hey, did you hear about the hungry clock? It went back 4 seconds. I love that joke, sorry. The title of this lesson is Solving Two-Step Equations, and I'm not sure why this is in my way, but it's there, so we'll deal with it. And the I can statement is I can solve two-step equations. There we go, it went away. Two-step equations using multiple operations. Here's a big hint for you. When solving two-step equations, you mostly work backwards from the order of operations. So we're doing everything backwards. So we've spent years teaching you how to do PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction, and now we're going to tell you to do it backwards. Don't you just love us math teachers? Okay, make sure you get your I can statement down and we're going to jump into some examples. Okay, we'll go to full screen. Notice this, show all work. That's so important for these because now they're two-step equations. It's very similar to one-step equations where we do the opposite, but we've got to do two things first. Notice it's 2x minus 15 equals 17. Remember a few things. This equation is like a balance. So if you had one child on one end of a teeter-totter and one child on the other end of a teeter-totter, and there's this fulcrum in the middle, right now they are not balanced because the left-hand side is heavier. Well, an equation that's true would be equally balanced at all times. So if I do something to the left-hand side, I have to do something to the right-hand side. In other words, if I'm going to add a kid, I have to also add a kid over here, because if I didn't, it would get off. One side or the other would go down and the other side would go up, right? So we don't want this, and we want this. That makes us happy in math. So let's do that with this example. Let me get rid of all my stick figures. I'm definitely not an artist, but I like stick figures. Okay, here we go. So we have, I'm going to copy down the problem first. We have the mission of isolating x, getting it by itself. The first thing I'm going to do is I'm going to add 15 to both sides. You may ask, why don't I divide by 2 first? Because this is 2 times x and division is the opposite of multiplication, and you'd be right. But remember, we're going backwards. So in PEMDAS, you always divide before you add, but now we're going to add before we divide. So I'm going to write this a little differently than I did last time. I'm going to write 2x minus 15 equals 17, and I'm going to write plus 15, which is the same as I did last time, except the last lesson when I did this, all that was left when we were done was x. But now what's going to be left is 2x, because negative 15 plus 15 is 0. So we just have 2x now. But 17 plus 15 is 32. So now we're left with the equation 2x equals 32. So now we divide by 2. And when we divide by 2, the 2's cancel on the left, of course, and you get 1. So x would equal 16. Again, we could check it. We could plug in 16 for x to see if it works. Let's see. 2 times 16 minus 15 should equal 17. 32 minus 15 should equal 17. And indeed, 17 equals 17. It's always good to check your work. All right, let's do a few more. All right, in this particular case, we've got some negatives to deal with. So one step at a time. We're going to add 10 to both sides because we start with a negative 10, and we're going to take care of the term. Here's a trick. Take care of the term. This is a term, this is a term, and this is a term. Take care of the term that doesn't have an x first. Get it out of the way. Move it. Get it gone so that you're left with just the x term. So when we do that, we get 0 minus 4x equals 44. And that should say plus 10. That's kind of sloppy. So now we can get rid of the 0. So negative 4x equals 44. We need to divide by negative 4 both sides because we want to make this 1 and just get x. So these are going to cancel. We have x equals negative 11 because 44 divided by negative 4 is negative 11. Okay? This next example, I'm going to show you how to write your workout slightly differently. Okay? I don't care if you write your workout like this, where you show the plus 10 with a line underneath it, or if you show it like this. So here's what I mean. In this case, remember, we're going to take care of the non-x term first. So we're going to get rid of the plus 5. So I have x divided by 9 plus 5. So here's another way I could write it. Okay, I'm going to give myself a little room here. Instead of writing minus 5 down here, another way that I could write it, and this is my favorite way, is I can subtract 5 and I can just write it right in the line. Okay? So plus 5 minus 5, we combine those like terms and we get 0. So we're left with x over 9 equals 6. Now I just want to show what I did there. I could have written it like this. I could have said, okay, we have x over 9 plus 5 equals 11. And I could have written minus 5 minus 5, x over 9 equals 6. I don't care if you write it this way, where you put a line underneath it and subtract, or if you write it all in the same line of numbers. Either way is fine, whatever fits your brain. Okay. Now we're going to multiply by 9 on both sides because we want to cancel out the 9s. So these 9s cancel, and relation wasn't obvious. 9 times x over 9 leads to just x because these 9s cancel out, and you're just left with an x. Okay. So x equals 54 here. And here's your last number clue. With this clue, you should be able to figure out the mystery number. It's between 51 and 59. Okay, here we go. Last example, I believe. Yes. Okay, I don't want this video to get too long. This is the one with fractions, but remember, whether it's fractions or decimals, we're going to do the same thing. Just because they're fractions or decimals doesn't change our approach to the problem. Okay? It just changes how we do the computation. So this time, I'm going to write out my work a little bit. I'm going to add the 1/3 to get rid of the 1/3. I'm going to do the opposite, but I have to do it to both sides. Okay, so these are going to cancel because a negative 1/3 plus 1/3 is 0. Over here, I'm going to have 1 and 1/3, and I'm still going to have 2/3 x. So now the question is, what do? We have 2/3 x equals 1 1/3. Well, we need to divide because this is 2/3 times x. So we're going to do the opposite. So we're going to divide both sides by 2/3. These cancel. We're left with just x equals, and then whatever this is. So I'm going to write this out. 1 1/3 divided by 2/3. First thing I'm going to do is I'm going to convert this into a mixed number. So that would be 4/3. Then I'm going to keep that. I'm going to change. I'm going to flip. Okay, I'm going to cross simplify and multiply across, and I get 2 over 1, or 2. So x is 2. And if we were to check this, if we were to plug in 2 in the place of x, we would test it like 2/3 times 2 minus 1/3 should equal 1. Well, let's see. What's 2/3 times 2? 2/3 times 2 is 4/3. I'll write that over here. Minus 1/3 equals 1. And this is a true statement because 4/3 take away 1/3 is 3/3, and that's definitely equal to 1. So that's how I checked my answer. I'm going through this computationally really fast. Like, I'm not explaining the computation because you are responsible for knowing how to add, subtract, multiply, and divide fractions. Okay, we've already done that. If you struggle with those, I need you to let me know, and I need to review how to do that with you. Okay, but in the videos, I don't want to take a whole bunch of time explaining it. But just because I'm not explaining it in the video doesn't mean I'm not willing to help you if you're struggling with how to divide and multiply fractions. All right, guys, good luck. I know you're going to do great.